So welcome. This question says a coil of wire consists of 20 turns. The magnetic field through the coil changes at a uniform rate from a flux of 8 Tesla meter squared to 14 Tesla meter squared in 4 seconds. And then what is the magnitude of the EMF induced in the coil? So the first thing I've got to do is visualize. So rather than a loop, I'm going to draw a coil. And I can say, well, my N, the number of turns, is equal to, in this case, 20 turns. And then I imagine a magnetic flux, that's my phi, going through the number of turns. And this is going to change. So I can say, okay, my flux initial is going to be equal to, goes from 8 Tesla meter squared, and my flux final is equal to 14 Tesla meter squared. And remember, I can think of this flux as being like the number of arrows that in this given area that go through that coil. So the number of magnetic field arrows going through that coil initially was only 8. And now it's 14. Okay. And this change took 4 seconds. It says in 4 seconds. So when the clock said 0, there was only 8 arrows going through, and when the clock says 4 seconds, you can imagine there's 14 arrows going through. It turns out that the flux is not equal to the number of arrows, but it's proportional to the number of arrows. So 8 and 14 gives you the ratio to the change. And I want to know what my EMF is. My EMF is going to be set up in the coil as a response to this change. When I change my flux through my coil, it induces an EMF in this coil, which tries to, because of Lenz's law, undo what we've just done. So what's my principle? My principle is that the EMF that's induced is equal to minus N, because it's more than one loop, d phi b by dt. And we can say, well, on average, this is equal to minus N delta phi b by delta t. And we can say my EMF is equal to minus N. And we can even break this up and say, oh, it's going to be phi b final minus phi b initial. The final flux minus the initial flux through the coil multiplied by the number of loops in the coil divided by, delta t. And so now I can start putting some numbers in, and I say, well, my EMF is equal to minus 20, and then it's going to be 14, that's the final flux, minus 8, which is the initial flux, going through the coil over 4 seconds. So that would be minus 20 times 14 minus 8 is 6 over 4. My EMF is equal to minus 20 times, well, 20 over 4 is 5. 5, 6 is a 30. Minus 60 volts. Minus 30 volts. And my magnitude, as for the magnitude, just how big is it? Magnitude, we'd put down as 30 volts. Because I'm asking for magnitude. Now, what does that negative sign mean? It gives you, it's a sign convention which tells you, is the EMF driving the current one way around the coil, or is it driving the current another way around the coil? Is it clockwise or counterclockwise? That's what's taking about. That's what's occurring there. So we had a coil. We had a change of flux in time going through it. That changing flux in time going through the coil induces an EMF. We use basically Faraday's law to get the value of the EMF, and then we wrote it as a magnitude. So there we have it.